Congratulations, you made it to the last video for our circles unit, which has been super long, so thanks for bearing with me. This one is talking about equations of circles, so I will be able to draw a circle given the equation and write the equation given a circle. So we're going to go both ways. So this is exactly what you'll see on your formula sheet, which is the equation for a circle. So the HK is the center point. So that is what you plug in here. And then the R stands for the radius. So we have R squared. Something to note about the center point is that when it is positive, they plug in with a minus. So if you had negative, so if you had like a negative H, negative K, that would make these into plus because X minus negative H becomes plus. So just so you are aware, that would make them into positives if you had negatives. So let's take a look at this example. First, I want to write what my center point is. So here that's been marked for me. So I see that it is 3, -1. And now I need to find my radius. Well, my radius I know goes from the center to the edge of the circle. So I can just draw a line. And since it goes along a straight part of the coordinate grid, I can just count. So 1, 2, 3, 4, 5. So the distance from the center to the edge is 5. So I know that my radius is 5. Now I can plug that into my equation. So I see that the X in my center point is positive, so I just write it in as it is. But then I have -1. So with that negative, I want to make this into a positive. And then put my 1, and then my radius is 5, so I write in 5 squared. And that's it. Let's look at it with a graph now. So if you slide your paper to the bottom, we're going to skip these 3 because you'll be able to do those just like we did here. But now if we slide all the way down to the bottom, we're going to be given the equation, and we want to go backwards from what we just did. Find the center and radius, and then graph it. So if our equation is right here, starting with my center, I'm going to take a look. I see 2 pluses here, which tells me that these are actually going to be negative for our center. Because remember, your formula has minus in there, so if you see a plus, this is negative. And then here I just see plain old 4. So I know that this part of my equation should be R squared, which you can just refer to from up here, so it should be R squared. So I'm going to do some quick math here. If 4 is going to be equal to R squared, to find just R, I can take the square root of both sides. And the square root of 4 is 2. So my radius is going to end up being just 2. Now that I have this information, I'm going to graph it down here. So I start with my center, -3, -2. And now I'm going to use that radius and just count that distance in different directions to help me find different points and plot my circle. So if the radius is 2, I'm going to go to the right 2 from the center. I'm going to go up 2 from the center, go over to the left, and down to the bottom. So now I've got these 4 points that can help me connect it in a circle. So just do your best. And now I've got this circle. And then let's check here. Sometimes a question might ask you if a point lies on a circle. So the best way to figure this out is to graph your circle and to then just look at the point. So -1, -2. If we go over -1, down -2, well, it looks like that is one of the endpoints of my radius actually. So yes, this does lie on the circle. If it had ended up somewhere in the middle parts of the circle between these points, use your best judgment to estimate if it lies on the circle, and if you are really doubting it, you can always plug this in. So you can plug it into the equation. So you can always plug this point here into your equation up here. Speaking of that, let's flip our paper over and try a problem like that. So if you are asked if a point lies on a circle given an equation, I want you to plug in the points. So this time we don't have a graph. I certainly could graph it, but I'm just going to plug them in. So let's start with answer choice 1. So I'm going to plug in the 1 for the x because that's the x in my point, and 5 is my y, so it'll be plugged in for y. So I have that 1 minus 4 squared plus 5 minus 2 squared. I'm going to want to know if this equals 5 squared. Well, I know that 5 squared equals 25, so I'm going to keep doing the math and see if I end up with 25. So 1 minus 4 gives me negative 3 squared, and 5 minus 2 gives me 3 squared. So negative 3 squared, remember a negative squared makes it positive, and 3 squared is 9. But 9 plus 9 is 18, which is not 25, so A is not the correct answer. Now I'm going to try answer choice B. So my x here is 0 minus 4 squared plus my y is negative 1 minus 2 squared. If I keep solving, it's 0 minus 4 gives me negative 4 squared, and negative 1 minus negative 2 gives me negative 3 squared. So negative 4 squared gives me 16, negative 3 squared gives me 9, and luckily 16 plus 9 is equal to 25. So since I got 25 here and my radius squared is 25, then B is the correct answer. Alright, just a little bit more to these notes. I'm not going to solve these, I just want to help you out so that you can do this in class. If you need to find the radius, we're going to be going back to distance from the beginning of the year. So you're going to need to use a squared plus b squared equals c squared between two different points in your circle to help you find the radius. So for radius, always think of a squared plus b squared equals c squared. If you look over at this problem here, you're actually given the equation and you're given a point on the circle. So since you're only given one point, remember every equation comes with your center point. So your center of this circle is 3, 1. And now you can use distance to help you find that using 3, 1. So between your center and this point that you're given. So again, I'm going to let you do these two in class. You may certainly try them now, but I just wanted to give you a head start there. Alright, the very last problem we are going to do, and you're all done. So here we are going to be given a circle with a diameter. So remember, our diameter is twice of our radius, and it gives us the endpoints here. So the first thing that I want to do is find the center of my circle, which is going to be using the midpoint formula. So as you can tell, circles deal with a lot of older stuff that we've learned. For midpoint, I want to stack my 2 points. So negative 3, negative 2, and 5, 4. After I stack them, I add down. So negative 3 plus 5 gives me 2, and negative 2 plus 4 gives me 2. And now I divide each by 2, and I get 1, 1. So midpoint will help me find the center when I'm given 2 endpoints. So now I'm going to jump over here and graph that center point, so 1, 1. And I'm going to graph those endpoints, so negative 3, negative 2, and 5, 4. 1, 2, 3, 4, 5, 4. Alright, from here I just need to find the radius. So to find the radius, I know it's going to be from the center to one of these endpoints. But unfortunately, this straight line here, I can't count it because it's going through all these grid lines. So I'm going to need to use my distance formula here. So if I count over 1, 2, 3, 4, and then I go up 1, 2, 3, I'm going to be using 4 squared and 3 squared to find what the radius is. So 4 times 4 is 16, and 3 times 3 is 9. I get 25 equals c squared, and if you square root both sides, you get that 5 equals c, which is our radius. And last but not least, you can graph your circle by connecting your endpoints. And we can write the equation of our circle using the center and the radius. So your equation is just going to be x minus 1, because that's a positive point, squared, plus y, again minus 1, because that is positive, squared, equals 5 squared, our radius squared. Great job, guys. Thanks for watching, and you are officially done with videos for circles.